Hello guys. So this tutorial is the remake of my old one, and I made it especially for the 5th Unreal Engine. So as you can see, we have clear sky, and we can go from this one to this one. It's dynamic volumetric clouds. There are a lot of tutorials that cover how to use static and default version of them, but they lack such features as shape-shifting over the time, multi-layered cloud system, and of course cloud movement. So we can download this sample via the link, and in the next couple of minutes I'm going to explain main features inside the logic so we can replicate it mostly from scratch. Let's get started. So the first thing to cover is multi-layered system. From this screenshot you may see that are lots of different type of clouds. As for previous in this tutorial, I'm gonna cover only two layers, cumulonimbus and stratus, and the way how I combine them can actually produce some cirrocumulus or cumulus or stratocumulus clouds. Also, a combination of those two layers can produce quite complex sky, and as you can see, cumulonimbus on the low altitude can produce precipitation. Also, if you add like additional layer, let me say as altostratus or cirrus, it can impact on your performance. Also, such high altitude clouds won't be seen too much, and people really doesn't care about how many type of clouds actually exist. So that's why I've chose this one and this one. We are back to our editor, and let me show you those layers. The first one is stratus, and you may see how they look. Let's add another layer, which is called cumulonimbus. And here they are. So, as you can see, with this combination of those two layers, we get quite impressive sky. Now let's talk about the logic itself. Here is my shader. It may look complex, but actually those operations are quite simple to replicate. And first of all, I'd like to cover this one. Those elements are called named reroute nodes. To make them, simply type for name and select this one. Then you can provide any type of data inside it, so they work as the shortcuts to keep your graph actually not quite messy. Also, you may say that, yep, I can use scalar attribute like this one, but I'd like to store everything inside the vector 4, because by having one attribute here, I can change the naming of each of my channel and make this one sort of category. So if I take a look at how my instance of material looks, you may see that I have already groups with ordered scalar attributes. So now let's talk about what elements you need to have to make it work. From the cloud tiling, you need to have global tiling, stratus tiling, and stratus detail tiling. The reason why I have multiplies here, because that's actually the way how you can simplify it, the number of zeros you need to provide for each element to change the tiling of each noise that we use for our sky. So in case if you don't have like this multiply here by 100,000 units, global tiling will be not 72 as I have here, but 100,000 units. Next, cloud coverage, where we have stratus coverage, stratus density, cumulonimbus coverage, cumulonimbus density, cumulonimbus global scale, Next one, cloud speed. There we have speed on both x and y axis. Cloud noise detail, it's the amount of like the scalar attribute that we will add to the texture, so it will get more like from white to black or from black to white. So stratus detail add, cumulonimbus detail add, and here is the neat trick on how to make different shapes for your clouds, and depending on the altitude of your sky, you can define the color of how your clouds are actually tinted. So we have curve atlas here with the name of cloud type by altitude and another attribute, cloud color. You can see that on your left here I use one atlas, it looks like this, but it's taught two type of linear color curve, cloud type by altitude and cloud color. We need to provide both of them, and the curve type should be normalized altitude layer, because this one returns normalized height of your sky from 0 to 1. And as you can see from like this one and this one curves, they actually are measured from 0 to 1. So for the cloud color I use RGB, and for the cloud type of altitude, R channel goes to the stratus curve and G channel goes to cumulonimbus curve. Now when we are done with those elements, let's start with our graph. The actual idea behind this shader, or the logic, is quite simple. Here I sample one texture 2 times with different tiling and also different speed. This texture is the volume texture of noise, Perlin noise. Each channel here stores its own pattern. And the way how it's computed, you may think of origami, when you have 2D layouts, and then it's the representation of the object in the 3D space. So, if we combine or sample this texture different way with different channels, we receive the noise pattern, like the volume with different shape. But then we need to make this shape more organic, to make it look as you like it to be. We need to multiply it over this one operation. Here we sample the 2D texture, cloud mask, and each channel here also stores its own pattern. So in this tutorial I use green channel here for the stratus cloud and blue one for cumulonimbus cloud. When you combine this one, for instance, with the result of like this noise, you will receive those fancy fluffy big clouds. So that's the whole logic. So sample one texture with different tiling, different speed, combine all together and multiply it by different channel of this texture. And yeah, that's actually it. So first thing to notice here is the way how I sample my textures. 2D texture is sampled the way that I need to extract vector 2 from world position and hour speed. For the volume texture, I need to provide the whole range from X, Y and Z. This one is the base shape of our noise. This one is detail that we actually mix up or add to the base shape to receive sort of details over the whole or the edges of our cloud. It also has slightly more speed multiplier, so that's why if we add everything together and take a look at how the clouds move, you will see that actually pattern shape shifts. Interesting here is this part. As you know, blue channel from our texture, this is cumulonimbus cloud. this big one that starts from the low and ends up to the high altitude. We need a mechanism to actually maintain this scale, and here comes this operation. It looks similar to this one and this one, but they serve different purposes. So to make it work as a switch, so if the scale is 0, everything is 0, and if it's 1, everything is fully sized, we need to subtract 0.5 and multiply it by 2 to shift the range from our channel, so it's not be from 0 to 1, but -1 to 1. Then it works, and we need to actually saturate the top of our calculations. So it's gonna back to normal from 0 to 1. Then we multiply the results of our noise by our curve cumulonimbus cloud. And here we have like our cumulonimbus cloud done. Next thing here, we need to provide the density. So how transparent or how opaque should our cloud be? So the same operation. Here we have for our stratus cloud the same logic also. Like this. Next, we add everything, so we get 2 layers combined, but results can also be higher than 1. To make it work perfectly fine, we need to saturate it and multiply by some small value. This value can be called like the global density and can be measured from 0 to 1. As you can see, I've changed setup one more time, so it's much more appropriate result to achieve from your extinction in the color. As for the color, as you remember, it's provided here by the curve atlas, and all you need to do is to multiply it by the normalized altitude, so the range will be expanded over the whole sky depth. Right now you can see my clouds, and I'm gonna change the values inside the color curve. Values that are closer to 0 are for bottom altitude, so I'm gonna make them a red one, and top one I'm gonna make green one. Now if we take a look at our sky, you may see that our cumulonimbus cloud that is on the high altitude is colored with the green one, and our stratus clouds that are on the low altitude is slightly red. One more time, slowly the whole graph. I also haven't said anything about these operations, but they are obviously easy to understand. If we have texture and we add the value to it, it simply goes more brighter or darker, and those elements add details for our noise. So, in case you don't want to use the sample project, you may stop the video or pause it and see everything one more time yourself. Also, don't forget to, it's very important, essentially important, to set blendable modes to additive and shading model to default lead. If you have your instance, you need to select it, then go back to Outliner and search for the volumetric cloud. Select it, and here in details, you need to look for material, and simply press this little button. Then your material will be applied over the component, volumetric cloud component. So, I completely forgot to tell you about this curve asset, where we define the shape and the moods of our clouds. As you remember, red one is for the stratus cloud, green one is for cumulonimbus cloud. For the sake of this demo, I'm going to change one of them, let it be Stratus Cloud, and I'm going to launch the game so we can see the results in runtime. So I'm going to add one more point somewhere here and change its position to something high. And now you can see that we have some fluffy, more detailed Stratus cloud that looks much more realistic. If you have the day and night cycle or the rain or the weather system, you can change all those attributes via the blueprint. So, as always guys, I hope you like this tutorial, kind of. Please subscribe to my channel, leave your feedback, press the like button, and in case if you want to support me, as always, I have the Patreon page. See you soon, guys.